Let's solve this problem. We want to find the length of the longest consecutive sequence in an unsorted integer array with linear time complexity. The first thing that I do is defining the variable longest equal to 0. At the end of the function, the variable is going to contain the result. As usual in this kind of exercises, maybe we need to scan every element of the array, so we can set a for cycle. Inside the cycle we can think, for example, in this way: if num is the start of a new consecutive sequence, count how many consecutive numbers follow starting from num, and eventually update the maximum length. How can I write if num is the start of a sequence? To implement this, I can write if num minus 1 not in nums. Maybe if it's not immediate, think about it. Think some seconds, minutes, and you will get that the sentence and the code are saying the same. And now for each num, I want to count how many consecutive numbers follow num. So in each iteration I can initialize a variable current equal to num and a variable count equal to 1, and I can define a while cycle that updates current and count based on how much consecutive numbers starting from num are in the original array. In the single iteration, if count is greater than longest, the results of the previous iterations, then the longest value is updated. Unfortunately, if I submit this solution, it doesn't work because we have to solve the problem in linear time. The problem is that when we scan all the elements of a list, the computational cost is linear, and this is not the best. This is why we can use here HashSet. Using HashSet, the total computational cost of the solution is linear. Then if I define in the code the new version of nums as HashSet, and I use it in the following steps, this new solution in this case works.